We've spent a few weeks, kiddos, in our algebra unit so far. We first started talking about and learning about expressions, and I've got an example of an expression in the top left. 3x plus 15 is an expression. And then we moved into equations, and remember, equations, we think of a balance or a scale that is equal on both sides. So 3x equals 15 is an example of one of our equations. And why? Because it's got that equal sign in the middle. So expression, no equal sign. We have some numbers, which this is a coefficient, this is a constant. We have variables, and we have operations like addition. But in order to turn an expression into an equation, we need to have an equal sign in there. So we're moving on this week in our algebra unit to what we call inequalities. And inequality simply means not equal. So you can see the balance that I'm showing you is no longer even on both sides. One side is lower or higher than the other. So when we have what we call an inequality, it means that one of the sides is less than the other. And we're going to know that because we're going to see an inequality sign. That means instead of an equal sign like we have here in our equation, we will see a less than sign or a greater than sign. And we will know that we are working with an inequality. One of your learning targets that I want you to be able to do today is notice the differences between them, to identify whether you're looking at an expression, an equation, or an inequality, and also know some things about them, recall some characteristics of each. So for instance, I want you to remember that our expressions cannot be solved. We do not solve expressions. We solved equations. We learned the last couple weeks to solve equations, and we did that with our inverse operations. So why do we say that we cannot solve expressions? Well, we don't have enough information here to find out what x is, and that's what solving means. Solving means doing what we need to do to find out what the value of the variable is. And we do not have enough information here in 3x plus 15 to find out what our variable is. The only way we would know is if I said to you x equals this, and then you can plug it in. But equations, we do have enough information. So I'm going to really quickly remind you that we can find what x is if we have an equation by going through our questions. I rewrote that equation. I'm going to look on the left. I see I need to get rid of the 3. The 3 is being multiplied times the x, so I'm going to do the inverse, which is divide. So that means x equals 15. And since we got a value of 5 for x, that is the only thing x can be. The only thing that I would be able to plug back into my equation to substitute in for x would be 5. There are no other values that work. So that means we can say under equation that there is only one solution. Equations have one solution always and one solution only. You know that after you've solved your equations, there is only one value you've always gotten for your variable. I'm pointing that out because inequalities are different. I'm going to write that inequality. 3x is less than 15. I'm actually going to solve it the very same way with the same question. So I'm going to draw my wall. Looking at the left, I see that 3 and x are being multiplied, so I'm going to divide both sides by 3. This time though, instead of an equal sign in the middle, I have to bring down the sign that's there, and that is less than. So think about what that means. X is less than 5. X is less than 5. X is not equal to 5. X is less than 5. So think about what that means that x could possibly be. Do you agree that x could be 1? Do you agree it could be 2? It could be 3? It could be 4? It can be anything that is less than 5. So I can prove that by going up to my 3x is less than 15. If I plugged in a 1 for x, that would be 3 times 1, which is 3, is less than 15, and that is true. I could plug in a 2. 3 times 2 is 6, which is less than 15, which is also true. If I plugged in a 5, though, 3 times 5 is 15. Is 15 less than 15? No, it is not. So that's why x can be anything less than 5, but it cannot be equal to 5, and it certainly can't be anything greater than 5. If I put in a 6 for x and tested it, 3 times 6 is 18, and 18 definitely is not less than 15. So when I get this solution of x is less than 5, that means x, the value of x that makes my inequality true, is any value that is less than 5. So on my equation section here, I wrote that we can only have one solution in an equation, but as far as an inequality is concerned, we can have more than one solution. So these things that I've written, you may want to be jotting down these little facts or even examples in your notebook so you can use them as you move forward today. One more point to make for us, you can see at the bottom, I have very similar inequalities. The only thing different is that the sign in between has changed each time. On the original one I talked about, we have a less than sign. This one in the middle uses a greater than sign. So this solution says that x is greater than 5. So think about what x could possibly be for this inequality. If it's greater than 5, it could be 6, 7, 8, it could be 200, it could be 5,000, anything greater than 5. I'm going to talk about these symbols. This guy is called less than or equal to. The one over here is called greater than or equal to. As soon as we stick in that little line underneath, we are saying that x can not only be less than 5, but it can also be equal to 5. That's a half of an equal sign along with a less than. So x can be 1, it can be 2, it can be 3, it can be 4, but it can also be 5 this time. Because of this guy right there, x is allowed to be equal to 5. Over on the right, I have this greater than or equal to. So that means x can be anything greater. Oops, and I forgot to put my line under there. X can be anything greater than 5. So it can be 6, it can be 7, it can be 8, it can be 150, but it can also be 5. Because of that line underneath, I'm saying that it's greater than or equal to 5. So x can also be 5.